Hey everyone, and welcome. Today we are jumping headfirst into the ESP32. It's this awesome, super powerful little microcontroller that is just packed with features. We're going to go from a totally fresh out-of-the-box board all the way to your very first working project, the classic blinking light.
So, let's say you've got an idea brewing for your next project. Maybe it's some kind of smart home gadget, or a weather station that tweets, or even a little robot. But then you realize, wait a minute, it needs to connect to the internet, or maybe talk to your phone. That's when you know you're going to need a brain that's a bit more powerful than the usual suspects.
Okay, let's break this down. On one hand, you have the fantastic Arduino Uno. It's the board so many of us start with, and for good reason. But if you want connectivity, you have to start plugging in extra modules or shields. But then you look at the ESP32. It comes with Wi-Fi and Bluetooth built right into the chip, no extras needed. And on top of that, it's got a much faster dual-core processor which gives you all the muscle you need for more complicated stuff.
Right. So, before we can start bossing our new board around, we need to set up the workshop where we write the instructions. So, let's get our coding environment all prepped and ready to go. First things first, we're going to need something called the Arduino IDE. That stands for Integrated Development Environment, which is just a fancy way of saying it's the program we use to write and upload our code. It's totally free. Just head over to the official Arduino website, grab the latest version that matches your computer, whether it's Windows, Mac, or Linux, and just run the installer. The default settings are perfectly fine.
So fresh out of the box, the Arduino IDE has no idea what an ESP32 is. We have to teach it. So open up the IDE and you're going to go to File and then click on Preferences. In that window, you're looking for a little text box called Additional Boards Manager URLs. We're going to paste a special web address right in there, which basically tells the software where to find all the ESP32 goodies.
Okay, so now that we've given the IDE the address, it knows where to look. The next step is to actually download the files. So go up to Tools, then Board, and then click on Boards Manager. This new window will pop up. In that little search bar at the top, just type ESP32. You should see the official package from Espressif Systems pop up. All you got to do is click that Install button and let it do its thing.
Awesome. Our software is all set up. Now for the fun part, actually plugging in the hardware. We're also going to tackle the single most common problem that people run into right at the beginning. This step is, well, it's about as easy as it gets. Just grab your ESP32 board and a standard micro USB cable. You know, the kind you probably have a drawer full of. And just plug it into a free USB port on your computer.
So you've plugged it in, you go into the software to select your board, and it's not there. Nothing. Okay, do not panic. I promise this is totally normal. It happens to pretty much everyone when they're starting out. Your board isn't broken, I assure you. It just means your computer needs a translator.
So, what is this translator? It's a little piece of software called a driver. The best way to think about it is like this. Your computer speaks one language, let's say English, and the ESP32 chip speaks another language. The driver is the interpreter that sits between them, translating everything so they can actually have a conversation. Without it, your computer doesn't even recognize that the ESP32 is trying to talk to it.
And here's the super simple fix. First, just take a look at the little black chip right next to the USB port on your board. A lot of the time, it's a chip called a CP2102. Just do a quick search for that chip name plus the word driver, and you'll find the download page. Install that little piece of software, and then, and this is the important part, completely close the Arduino IDE and open it back up again.
All right, with the IDE restarted, go back up to the Tools menu and then hover over Port. You should now see a new option that wasn't there before. On Windows, it'll probably look something like COM6. That's it! That's your ESP32. Go ahead and click on it, and you have officially established a connection between your computer and your board.
Okay, we've got the software ready, we've got a solid hardware connection. It is time. Let's write our very first program. We're going to make that little onboard LED blink. This is the official hello world of the entire electronics world.
Okay, just one last little setup step before we type. Go back to Tools, then Boards, and you'll see a whole section for ESP32 boards. There's a long list here, so you need to find the one that matches your specific board. Usually the name is printed right on the back, something like Node MCU32S, and here's a key piece of information you just need to know. That tiny little blue LED that's built right onto the board, it's wired up internally to pin number 2. All right, let's look at the actual code. Every single one of these programs has two main parts. The first part is called Setup. Anything you put in here runs only one time, right when the board powers on or you hit the reset button. So here we're using a command, pin mode, 2 output. This is us telling the ESP32, hey, that pin number 2, we're going to use it to send signals out.
So what exactly is pin mode doing? Think of it like setting the direction on a one-way street. We're telling pin 2 that the traffic, which in our case is electricity, is only going to flow out from the chip to control our LED. Now, if we were using something like a button or a sensor, we'd set the pin to input because we'd want to read data in.
Now, for the second part of the code, the loop function, this is where the magic really happens. Anything you put inside this loop will repeat forever and ever and ever as long as the board has power. So our first command in here is digital write to high. This is the command that actually turns the light on.
And digital write is basically the light switch. When we tell it to write high to a pin, we're telling it to send voltage out of that pin, which turns our LED on. And when we tell it to write low, we're telling it to cut the voltage, which turns the LED off. It's really that simple. It's just a digital on or off command.
Now, if we just turn the LED on and then immediately in the next line of code turned it off, it would happen so ridiculously fast that our human eyes wouldn't even see it blink. We need to tell the ESP32 to just pause for a moment. And for that, we use the delay command.
The delay function is beautifully simple. It literally just tells the microcontroller to freeze and do absolutely nothing for a specific number of milliseconds. So when we write delay 1000, we're telling it to wait for 1000 milliseconds, which is exactly 1 second. This is how we'll create that nice visible blink.
Okay, we have our full blink program. It's time to send it over to the board. Go ahead and click the little right arrow icon in the IDE to upload it. Now here is a super important tip. As the software starts compiling, you might need to press and hold the tiny little button labeled boot on your board. Keep holding it until you see the message change to uploading. Once it's finished, you can let go and hit the reset button, and you should see that little blue light blinking at you.
And just like that, you have a blinking light. Now I know, it seems like a small thing, but what you just did is the fundamental building block for literally every other project you're ever going to build with this thing. So let's just take a second to recap what you actually accomplished here.
I mean, really think about this for a second. You set up a proper professional coding environment. You ran into the #1 problem that trips up beginners, that hardware driver issue, and you solved it. You wrote your own program from scratch, you sent it to a microprocessor, and you made something happen in the real physical world. That is a massive accomplishment.
So, your little blue light is blinking. You've proven that you can control it. But I want you to remember, this isn't just any old microcontroller. This board has Wi-Fi, it has Bluetooth, so the real question isn't if you can make cool things anymore. The question is, what are you going to make